Helicopters can do something airplanes can't: hover in midair, fly backwards, and land on rooftops. But how do they actually fly? Unlike airplanes that need wings and forward speed, helicopters use spinning blades to create lift and control their movement in any direction. Let's look at the main parts of a helicopter. The main rotor blades, rotor hub, cockpit, engine, tail boom, tail rotor, and landing skids. The main rotor blades are the heart of the helicopter. They work exactly like rotating wings. As the rotor blades spin, they create lift using the same principle as airplane wings. Bernoulli's theorem. Fast air on top creates low pressure and slow air below creates high pressure, pushing the helicopter up. The rotor spins at high speed, typically 400 to 500 revolutions per minute, creating enough lift to overcome the helicopter's heavy weight. The pilot can change the angle of the rotor blades to control how much lift is produced. This is called the angle of attack. The collective control, located on the pilot's left, changes the angle of all rotor blades at once, making the helicopter go up or down. When lift equals weight perfectly, the helicopter hovers in place. A maneuver airplane simply cannot do. But there's a physics problem. When the main rotor spins one way, Newton's third law says the helicopter body wants to spin the exact opposite way. The tail rotor solves this by pushing air sideways, creating anti-torque to keep the helicopter body stable and facing forward. To move forward, the pilot uses the cyclic control to tilt the entire rotor disc forward. The cyclic changes the angle of each blade individually as it rotates, tilting the lift vector in the desired direction. When tilted forward, some of the lift becomes thrust, pulling the helicopter forward through the air. Tilt the rotor backward and the helicopter flies in reverse, a unique capability of rotorcraft. Tilt left or right and the helicopter moves sideways with incredible maneuverability. Foot pedals control the pitch of the tail rotor, allowing the pilot to turn the helicopter's nose left or right. So helicopters have three main controls: collective for up and down, cyclic for direction, and pedals for turning. During takeoff, the pilot increases the collective to generate more lift than weight, lifting off vertically. To climb higher, the pilot raises the collective further, increasing the blade angle and gaining altitude. If the engine fails, helicopters can safely land using autorotation. The upward airflow keeps the rotors spinning like a falling maple seed. To land, the pilot reduces the collective gradually, decreasing lift for a gentle, controlled touchdown. Helicopter blades are specially designed with a twist, a steeper angle at the root, and flatter at the tip for even lift. At high speeds, the blade moving backward gets less airflow, causing retreating blade stall. This limits helicopter top speed to about 250 miles per hour. Hovering requires constant small corrections. The helicopter is naturally unstable and wants to drift in the wind. Near the ground, helicopters experience ground effect, extra lift from compressed air bouncing off the surface, making hovering easier. From small two-seaters to massive cargo helicopters, the basic aerodynamic principles remain exactly the same. Unlike airplanes that need long runways, helicopters can take off vertically, hover, and fly in any direction. Because of this, they are used for rescue missions, medical emergencies, news coverage, and military operations. In summary, helicopters fly by using spinning rotor blades as wings, controlling lift with the collective, direction with the cyclic, and stability with the tail rotor. The next time you hear a helicopter overhead, you'll understand the amazing physics that keeps it flying. Thanks to Bernoulli's theorem, Newton's laws, and brilliant engineering. Subscribe to Handkerchief for more.